In this video, we're going to talk about significant figures. Imagine that we actually measured something to get this measurement here, and the digits that actually are part of the measurement that we made are significant, as opposed to the digits that are only there to tell us the place value of what we measured to are not significant. I'll try and explain that here, but because these zeros are between significant digits, non-zero numbers are always significant. Zeros are significant if they are between significant digits. So there's four significant digit or significant figures here, and it's significant to the nearest person, right? Nearest whole person, because we actually measured ones of people there, right? That's where we measured to. Whereas this number, 510,000, we would imagine that all of these trailing zeros are not significant, and that the last significant digit is that one there. So we have two significant figures, and that is significant to the tens, 10,000s place value. We would say that this 2 here is the last significant figure, and probably the 4 and the 2 are the only significant figures, where these leading zeros here and between the decimal and the first significant figure that we see are not significant because they're just part of place value. So we have two significant figures. Significant digits, and let's see that 2 is in the let's write that in scientific notation to help me. That's 4.2 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, right? So that's in the 10 millions. Place. Let's see if that's right. Tens, hundreds, thousands, 10,000s, millions, 100 millions. There we go. Because that's 10 millions, that's 100 millions. So, all right, we have 1, 2, 3, 4, 5, 6 meter. Before I go on here, I'm going to say that this is probably better to not talk about this in meters. This is probably going to be measured as something like I think that would be 420 nanometers or something like that, or 0.42 micrometers, something like that. So you would measure it in a much smaller unit to get rid of all these zeros, and you would use a place value to help you with that. So this is unusual to put this many zeros in a measurement like that, and then to not use a smaller unit of measure there. All right, this one has 1, 2, 3, 4, 5, 6 significant figures, and it's measured to the nearest thousands, 10,000, 100,000th of a minute. Thousandth of a minute. It's really small, right? And then this one is pretty big. If we look at this in standard notation, standard form, it's probably going to help us. 2, 3, 4, 5. Now, the implication here is that because these zeros are here after the decimal point, that they are significant. So all of this is significant. I assume we have 4 significant figures, that those were actually measured values. And so it's to the nearest 2, 3, 4, 5, 6. Hang on. I put my comma in the wrong place. There's 3, 3, 4, 5. There we go. That's better. And all of this was measured, so it's to the nearest 100,000 is the implied precision. All right, that's it for, we got a couple more here. So because there's a 0 after the decimal point there, we assume that this is precise to the nearest tenth, and that there is 4, 5 significant figures here. This one has 4 significant figures, and it's to the nearest tenth. And this one has 4, 5, 6, 7 significant figures, and it's to the nearest thousandth. Okay. We will come back and do some arithmetic with sig figs next time.